In the topology slang, the terms pulses and levels are quite important. Back to the analogy of our drive as a black box, it is safe to say that the term pulses relates to the input side and the term levels refers to the output stage. Looking at our basic diagram, you notice that the output voltage will be created by connecting the plus and the minus at a switching frequency following a pulse width modulation pattern. This switching between two levels makes this a two-level drive. And yes, this is a three-level drive. Notice that the face-to-face output voltage of the three-level inverter is made out of 5 steps and is already looking much better than the two-level output voltage. Some manufacturers also offer a 5-level inverter, but it must be noted that if the 3 or 5-level inverters are to drive a standard motor that is not inverter duty, these inverters will require a sine wave output filter in order to reduce the common mode voltage and the voltage stress on the motor. These supplemental output filters can be of a significant cost and might also introduce performance restrictions on the power driver system. Moving further in our topologies overview and adding in more levels, you are now to discover the Modular Multilevel M2C MMC topology. Notice in the basic diagram of the Modular Multilevel Inverter that the centralized DC capacitors are no longer present. Instead, we find capacitors for each power cell within the inverter part. The low voltage energy level stored in each cell results in an improved fault behavior as compared to other drive topologies. In the simplest case, such a power cell consists of 2 IGBTs and 1 capacitor bank. Medium voltage levels are obtained by adding together the outputs of multiple power cells. We can state that this drive delivers a superior sine wave output voltage and current, thereby eliminating harmonic heating and insulation stress on the motor, and reducing significantly the torque pulsations to levels lower than 1%. Next in our topology overview is the 2-level series connected multi-level cascaded H-Bridge cells topology. What a mouthful. The multi-level cascaded H-Bridge cells topology adds up the output of multiple low voltage power cells to obtain medium voltage levels. Each power cell is a simplified version of a standard 2-level PWM low voltage converter. Many applications, including low voltage drives, use low voltage IGBTs. They are manufactured in very high quantities. Medium voltage drives that utilize low voltage devices can take an advantage of rapid innovation cycles, exceptionally reliable components, and a sustained availability of spare parts. The result of adding up the output of multiple low voltage power cells is a high quality output voltage providing less than 1% induced torque ripple, no need for an output filter for motor cable lengths even up to 2 km, a high reduction in common mode voltage, no derating on new or existing motor, no voltage spikes at the motor thanks to small output voltage steps, thereby indeed allowing the use or the reuse of a motor with standard insulations, ideal for retrofit. The integral dry multi-winding transformer provides for adaptability to available input voltage, clean input power thanks to the cancellation of the harmonics by the phase displacement in the secondaries. Multi-pulse inputs go from 18 to 54. Isolation from the grid, avoiding potential resonances and reducing impact from utility transients such as lightning and other equipment switching. This architecture, however, does not allow for regenerative operation or extremely quick deceleration, an active front-end version of this architecture is rarely economically viable. You can use this kind of drive for general purpose applications. For the more demanding applications with 4-quadrant and high dynamic response, you will need to look into the more advanced topologies.